All right, good morning, everyone. My name is Anders Halsberg. I'm a technical fellow at the developer division at Microsoft, and I'm here this morning to talk about TypeScript. And sorry if my voice sounds a little funny. I'm getting over a cold my daughter brought home. So over the last at least 5 years or so, I would say we have increasingly heard from customers and internal teams even that writing large applications in JavaScript is too hard. Today, we have teams and customers writing with regularity 100,000-line JavaScript apps in a programming language you could argue was intended for 100-line apps originally. JavaScript doesn't have any means of structuring large applications, really. There's nothing beyond functions. There are no classes. There are no modules, and so forth. And also, JavaScript doesn't have any static typing at all. It's an entirely dynamically typed language. And if you think about what has powered the tooling revolution that we've seen over the last 10 years, super intelligent IDEs with code completion, code navigation, refactoring, find all references, go to definition, et cetera, it's all at the bottom of it powered by static typing, the ability for the IDE to more deeply understand what goes on in your code. So 2-3 years ago, when we were thinking about where to go next with our JavaScript development tools, we thought it would be really neat if we could strengthen JavaScript with some of these things that are missing for large-scale JavaScript application development, such as classes and modules and optional static typing, but do so in a way that doesn't actually in any way compromise the true value of JavaScript, which is that it's cross-platform, open standards, web, and so forth. And TypeScript is the outcome of that. TypeScript is see if we can is basically a language for application scale JavaScript development. That's sort of the marketing speak line. What it actually is a statically typed or optionally typed superset of JavaScript that compiles to plain JavaScript. And the TypeScript compiler is itself implemented in TypeScript, and the code that it generates, the JavaScript that it generates, runs on any browser, on any host, on any OS. And the TypeScript compiler and the language service are open source. Whoops, I think I got one too far there. Now, TypeScript starts with JavaScript. Unlike certain other languages that target JavaScript, we actually start with JavaScript, which means that any piece of JavaScript code is also valid TypeScript code. You can just copy and paste the code. Also, it means that TypeScript works with all of the existing libraries and frameworks that are out there in the open source domain, like Node.js, jQuery, underscore, Backbone, Express, Prototype, et cetera. Now, on top of JavaScript, then, TypeScript adds optional static typing, classes, and modules. And those are the things that enable us to build great tooling experiences for large-scale application development on top. But the cool thing is that all of these language extensions essentially compile away. When you compile and your TypeScript becomes JavaScript, it's basically just idiomatic JavaScript, the JavaScript that you would have written to do classes or modules using the prototype pattern or the closure pattern and so forth. And as I said, the final code runs on any browser, on any host, on any OS. So currently, we have a preview of TypeScript out there. Let me actually ask, how many of you have looked at that already? Oh, quite a few, but there's, okay, great. But so what I'm going to do now is try to do some demoing of, get the right switch here. Up. I'm going to try to do a little bit of demoing of TypeScript, both in a browser and in the Visual Studio IDE. I'm going to start in the browser. Here I have a local copy of the TypeScript website. And part of the website is a thing we call the playground. And the playground is a little place where you can type in TypeScript code and then see the compiled JavaScript code to sort of learn what TypeScript does and so forth. The thing that's cool about this is that behind this edit box over here, there's actually the full TypeScript compiler and language service. So as I'm typing, we're compiling, and then we're putting the output code over in the other window. Let me start with a real simple little piece of code here, just a function, a JavaScript function. And I don't know why that stuff is showing up there. I'm wondering if we could get that to go away. Hopefully we can, because we can't see what I'm doing. Anybody? All right. Well, let me try to move my window over while you guys work on getting it to go away. Okay. Is it gone? All right. Excellent. All right. We're back. Thank you. Thank you. Hopefully I'll get more applause than that. Okay. So here's just a plain old JavaScript function. And the thing you'll notice is that it compiles to exactly the same code on the other side. Now, if you look at this function here, there's something a little bit suspicious about it. You know, it takes a parameter x, then we add a property to x, but then we also add x together. And clearly that probably wouldn't work, but there's actually nothing wrong with this. Is perfectly valid JavaScript. It is just not meaningful JavaScript. But no one's telling us that it's not meaningful, and we don't actually find out until we run the code, right? But let's say that we knew, for example, that x is a string. Well, wouldn't it be nice if we could annotate that and tell the system that x is a string, and then have it check for us whether we're doing things that apply to strings? And it's not like we're the first to think of this. Other people have too. Like if you take the Google's closure tools, for example, they allow you to put type annotations in comments using JSDoc syntax like that up there. And that works. But I would say having your type system in comments is probably not the best place to have your type system. It's not particularly expressive, and it's sort of duplicative. So what we do in TypeScript instead is to simply allow you to put the annotations in line. So I could just say x of type string. And once I do that, then the tooling starts to light up. You see that I get some red squigglies here, and if I hover, it tells me that that name does not exist on type string, because there is no name property on string. Now, the other thing, though, is you'll note that we've concluded that string plus string equals a string. So if I hover here, we see that the type of v is actually a string, and that's okay to pass to alert because it expects a string. It's a method that expects a string. But let's say that x was of type number instead. Well, now x plus x, if we hover over v, you'll see is a number. But now we get an error here saying that that doesn't match the expected call signature of the alert function, which wants us to give it a string. So again, we get this error checking. Let's say I made it a, let's say I made it a bool. Jeez. Here. And now you'll note that the compiler complains that you can't apply operator plus to two booleans. So static type checking can catch all of these things that you otherwise would have waited until runtime to find. Now, of course, primitive types is one thing, but we also allow you to annotate something as being of a more structured type. Here I'm saying now x is a string array, so now if I index into x and press dot, you'll see that we can give you statement completion on all of the members of string because we know what it is now. I could also, for example, annotate it to be a function that returns a string, and now if I call x and say dot, you'll see that I get those members. But perhaps even more interesting, I could describe the shape of x. I could say x is an object that has a number property called a and a string property called b, like so. And now, if I say dot on x, you'll see that, oops, I don't know what I typed here. If I say dot on x, you'll see that we know that there's an a property of type number and a b property of type string. Let me modify my code to, for example, return x.a. Sorry for my bad typing. like so. So types can be written in line like this. And basically, TypeScript has a structurally typed type system, so you can write types in line, but you can also give them names. So for example, I could declare an interface or a type, just a shape of type called thing that has an A and a B property, and now I could modify my code to just take a thing, and the result would be the same. Let me try to now, for example, say var n equals process of, and then let's try to pass a colon 10 comma b colon hello to my function. And you'll note that I'm not getting red squiggly, so one thing here that you see is that you can implement interfaces simply by providing object literals that have the required members, in this case, A and B. We could actually, well, another thing that's interesting to note here is that because A is of type number and we return x.a, then we have concluded that the return statement produces a number, and therefore we can conclude that the process function is a thing that takes a thing and returns a number. Because you hadn't specified a return type annotation, we can infer that. And that means in turn that when we call process, then we get something that is of type number. So down here we've concluded that n is of type number. So you see the types flow, and you don't actually have to provide type annotations for every single identifier that occurs in your program. In fact, it's quite remarkable how few you have to provide, and then we can infer the rest. Let me actually just, for kicks, take what I've started with here, and then let's switch to Visual Studio and continue over there with the same piece of code. So the TypeScript language service that you saw running in the browser, we also can run inside Visual Studio. In fact, we can run it anywhere that JavaScript can run. So we can run it in a Chrome browser on a MacBook or whatever. You know, it's just JavaScript at the end of the day. Here I'm showing you part of our TypeScript preview that's a plugin for Visual Studio that gives you the same capabilities inside the Visual Studio IDE. So let's try to continue on a little example in here. Let's say that I added another property to my interface. You'll see now that I get a red squiggly down here saying that there's something missing from the argument that I passed. Now, it turns out that it's very common in JavaScript to have optional properties, like when you pass options bags and so forth. So TypeScript actually, the type system allows you to mark a property as being optional. So I can say C is optional. And now, obviously, I didn't supply it down here. If I do supply it, I must supply a Boolean. If I give a number, then again I get an error because I gave the wrong type of the optional property. So optional just means if it is there, it must be of the given type. Let's try to explore a little bit more what you can do with type annotation. So I might, for example, declare that foo has a method that takes a string and returns a string. And now when I say x dot, you'll see that there's an A and a B and a foo. And if I pick the foo, then I get statement completion on the argument. So if I pass it ABC, and then because it returns string, well, then we know that the process function now returns a string. I can actually overload these guys. So I could have two versions of foo, one that takes a string and one that takes a number. And now down here, if I do open paren, you see that there are now two overloads, and if I pick the number guy, then, well, we'll conclude that the function returns number. Now, the thing that's interesting about this is that overloads occur a lot. Now, you're going to go, well, what do you mean? You can't have two implementations of foo in JavaScript. There can only be one function. That's true, but from a statically typed perspective, it is very common to have the return type of a function depend on what arguments you pass it. If you look at jQuery, for example, the dollar object is callable, and it has 7 different overloads where if you give it a string, then it gives you back a selector. If you give it an options bag, if you give it a callback function, if you blah, blah, blah. And we can actually, by supporting overloading, model all of these things such that we can truly give you the right development experience. Now, the thing that's interesting here is if I try to paste this in, what I just wrote the two overloads of foo is really the same as writing this, where I say there's a foo property, and it has two call signatures, one taking a string, returning a string, and one taking a number and returning a number. But I could also add, say, a data property to my foo. And now you'll note that if I select foo here, so I say x dot foo, you'll see that if I say dot, there's a data property. If I say open paren, there are two call signatures on foo. Now you're going to go, well, what's that? Well, it turns out in JavaScript, you can have properties on functions, and our type system allows you to model that. So you can say, here are all the ways you can call your function, and here are all the static properties on the function. Now, just for completeness, we also allow you to declare constructor signatures, so you can say that that thing is a constructor function that takes a string, and we can define what it means to index it. And here, for example, we've said if you index a thing, then you get back dates. So now, if I index into it, you'll see that I get dates. If I say new on it, you'll see that I'm supposed to pass a string, and it returns me an HTML element. So you can basically, and the crazy thing is that, of course, an object like this wouldn't occur in the wild, but combinations like this do in the DOM, in HTML, in jQuery, in all of the various frameworks that are out there, and TypeScript allows you to model it. In fact, TypeScript's type system is really just a static manifestation of the JavaScript type system. It is a notation that allows you to write down the type system that actually exists in JavaScript at runtime, so you can reason about it at development time. All right. Let's get rid of this, and let's try just show another example of some code. Here's a little piece of code that implements a very typical pattern in JavaScript. It has a local variable, and then it has some local functions that close over that local variable, and then the outer function returns an object with function properties on it. And this is the closure pattern that allows you to capture private variables and get privacy. Very, very typical in JavaScript. Now, you'll note that I've added only one type annotation to this code here, where I've said this value parameter is of type number. But we can actually infer all of the rest. We can infer that sum is a number, because we're assigning a 0 to it. We can infer that we're returning an object with three properties called clear, at, and result that are of various function types. And therefore, our make accumulator is a function taking no arguments that returns an object having three properties, each of a function type, et cetera, et cetera. So we basically infer all of this, and I wrote only one type annotation. Now, in order to use it, I can now say var a equals make accumulator, and now you'll see that there's an add method here that I can pass 5 and so forth. So that's inferring from code that you've written. Now, often you want inference to go in the other direction, or you may, for example, already have an interface declaration here. Let me try to paste one in. That declares some interface that you want to implement. Let's say an accumulator interface, and let's say my make accumulator is supposed to implement that interface. I can then annotate it and say it's supposed to return an accumulator. And now the compiler will check in reverse that I am implementing that interface. In this particular case, I am, because I'm not seeing any red squigglies. But imagine that I had typed something wrong here. Now, all of a sudden, I get red squigglies. And if I hover, you'll see that it, in great detail, actually tells me, if you look at the very end of it here, it says missing property add from accumulator. Now, this is the kind of thing that is super, super useful for tools to do. Like, this pattern is very common in JavaScript, and often you have functions that could be 1,000 lines that return a 100, 200-line object literal with local functions in it, and you typed something wrong in there somewhere, and nothing will tell you. And you just better have unit tests for every line of code you wrote with every possible combination of parameters, or else you won't know. But this stuff will tell you right away. Now, one thing that's interesting here, too, by the way, is that I can now actually get rid of this type annotation. Because we know that I'm implementing an accumulator here, then we can automatically relate what the function literal that you're writing to the type that it is implementing and conclude that values of type number without me even having to say so. And so now I don't have to write any annotations in here practically. This actually turns out to be useful in other cases. Let's say that I wanted to write an event handler for on mouse move. So I'm going to just go ahead and type window.onMouseMove equals function of E, and then I'm going to say E dot. And you'll note that we actually give you statement completion here without you having said anything about what E is. And you'll note that we've concluded that, oh, that's a mouse event. Now, the reason we've concluded that is because on mouse move is, well, first of all, you look at we know what window is, and we know that window has a property on mouse move that is of a function type that takes a mouse event and returns any. And if you assign to that, well, then we can relate that to E, and now we know that E is a mouse event, and therefore we can give you statement completion on E and so forth. So again, rich type inference allows you to get all of the benefits of static typing without you having to explicitly say the types all the time. Cool thing actually is we can just go to definition of on mouse move, and you'll see that I now pop into a file called lib.d.ts. This is what we call a declaration file. This is the declaration file for the entire JavaScript runtime library and the DOM. It's about 8,000 lines of stuff. This is the 8,000 lines of stuff that you are supposed to keep in your head when you're writing JavaScript code and you type dot and nothing happens, right? That's crazy. That's just not a good use of gray matter. So this stuff basically will serve up that information for you on demand, right? That's what tools are supposed to do. Allow you to do the creative work, and they'll do the lookup work for you. So now we can actually navigate around in here. We can go look at the definition of mouse event, and here you see the mouse event interface. The thing that's interesting about this file, by the way, is that all of this stuff is standardized, and there's a standardized set of IDL or interface definition language files for the DOM and the JavaScript runtime library, and we just auto-generated this file from that. And there are often cases where you're talking to APIs where the metadata is available. If you look at Windows 8 and the new WinRT runtime, it's all described in metadata, and we can actually run auto-generators on the metadata and produce the declaration files for the TypeScript that corresponds to the APIs. The other thing that's really noteworthy about this is that I didn't have to go modify the JavaScript VM or anything in order to get this type information. You note that it's delivered in an adjunct manner in a separate file, right? So if I have a declaration file, then the tooling can do stuff for me. If I don't, then it's just like JavaScript. But the cool thing, too, is that all of the existing libraries in the industry, like jQuery, Node, and whatever, we can write declaration files for those without modifying the libraries. And that's actually what we've done. And part of the TypeScript distribution is static typing for Node, jQuery, and some other examples. And right now, the industry has already, the community has picked up on that. We know today, we know of 73 different declarations for external or for libraries out there. There's a website called Definitely Typed on GitHub, where a guy is actually collecting all of them, and it's really cool to see the community run with it, because that was exactly our intent. Okay, let me try to go back to the slides here, just make a few comments about that. So you saw that TypeScript's type system is basically just a formalization of JavaScript's type system. It's not like we're trying to invent something new here. We're just trying to formalize what already exists. You see that we have rich type inference and structural typing, and in practice you end up writing very few type annotations. We work with existing JavaScript libraries, and for the type system geeks, this is not a provably type-safe type system. This is, in a sense, the thing that's interesting about this is a type system for tooling's sake, not a type system for performance sake or for correctness sake, if you will, because after all, we're trying to type JavaScript, and anything is valid in JavaScript, right? So we're in a sense just defining a semantic subset of JavaScript, the semantic subset that makes sense. And that's the one that we're enforcing, if you will, right? Okay, let's try to look again at classes and modules. As I mentioned earlier, we support the ability to write classes and modules. And again, I think it's fun to do that in the playground here so you can follow along. Let's try to write a class. So I'm going to write a class point. In point, I'm going to say it has two properties, x colon number and y colon number. And then I'm going to say make myself a new point, like so. And then I'm going to say x dot, and you'll see that, whoops. Sorry, not x dot, p dot. And you'll see that we now know that p is a point that has two properties, x and y. So let's try to assign to those. P dot y equals, let's see, do we get that? Yep, p dot y equals 20. Good. So if you look at the generated code, this is actually kind of the code that you would write in JavaScript yourself, at least if you're following good idioms and practices. An outer function that wraps it all, and in that outer function we have a constructor function, and that's what we return from the outer function. Now there are of course no members or anything in it yet, but we'll see what happens. For example, let's say that we wanted to pass the x and y to our constructor. Well, if we do right now, the system complains because we haven't written a constructor, and so we better go write one then. So let's say constructor, of x colon number, comma y colon number, like so. And in here, we'll say this dot, and you'll see that we get statement completion on the members of our class. So this dot y equals y. Now, this syntax is essentially the syntax that is proposed for ECMAScript 6 classes, plus the type annotation stuff that we add on top. But in many ways, TypeScript is a preview of features that are coming in ECMAScript 6. We have aligned all of our extensions very closely with what is currently proposed for ECMAScript 6, so for classes, modules. We also support arrow functions, REST parameters, default arguments, et cetera, et cetera. All of these things align. And of course, that also means if before we ship, although I don't really know what it means to ship in open source land anyway, because we ship every day, but before we declare it done, if ECMAScript 6 moves to a different model, then we will likely follow, because we are still just a preview of what the final product will be. Okay, so if you look at what happened to my constructor, the code ended up in the constructor function, which I return out. And again, this is kind of the idiomatic JavaScript that you would have written. You can declare methods here. Let's declare a dist method, and you'll see here if I use the math object from JavaScript's runtime library, I get statement completion on that, which is very nice. And in here, say I want to return this dot x times this dot x plus this dot y times this dot y, for example. And now, if I go down here and I say p dot, you'll see that now there's a dist function that returns number plus my two properties that I already had. And if you look at the generated code, you'll see that instance variables go on the instance in the constructor function, but methods go on the prototype. And again, this is exactly how ECMAScript 6 classes are proposed to work. We actually also support an ECMAScript 5 feature called accessors. I could make this into an accessor function by typing get space dist. And now you'll see that our code generation changes and makes an object.define property, because that's how you define accessor functions in JavaScript. And if we look at p dot, you'll see that we now, you'll see that we now have a dist property, not a dist method. Okay, let's get rid of that again. Okay, now we also support static members, so I could say there's a static origin equals new point of 0, 0, for example. And you'll note now in the generated code that we put the static members on the constructor function, methods go on the prototype, instance members go on the instance, and so on. If we look at now say point dot, you'll see that there's now a point dot origin, which is of type point. There's also a point dot prototype, which every constructor function has, and that is also of type point. So we can go and poke things on the prototype ourselves if we wanted to. Okay. There are some other niceties in our class model. For example, this pattern of declaring some members and then initializing, then having a constructor that takes those arguments and then initializing those arguments in the constructor is very, very common. In fact, it's common enough that we support something that we call automatic properties, where you can just get rid of all of that, and then you can just use a public modifier on the constructor arguments. And that means that I want a public property with the name of this argument, and please initialize the property to the value of the argument. And you'll see that we end up generating the same code, but it's a lot more succinct at that point. Another feature that we support from ECMAScript 6 is default argument values. I could, for example, say that these default to 0, and you'll note in the generated code that we inject a check for undefined, and if so, provide the default value. And now also the type checker knows that the arguments to the constructor are optional, so I don't get errors if I remove them. Okay, so that's classes. Classes also support derivation or inheritance. Let's try to write class point 3D. Extends point, like so. And now let's just pause here and look at what happened in the generated code. So we still have our our class point over here. Now we also have a point 3D. You'll note, and since this is a derived class, we pass the base class as the argument to the function closure. Call it super in here. And then we automatically generate a call to the base class constructor. But then we also inject a call to a helper method called extends that sets up the prototype chain. And if we look at extends up here, it basically just says, if I haven't been defined, then define me, and now do whatever magic it is you have to do to set up the prototype chain in JavaScript. Now, this is the only time that we will inject foreign code into your code. TypeScript doesn't have a runtime library. TypeScript's runtime library is JavaScript's runtime library. But there are certain things that are, inconvenient to do in JavaScript, like setting up the prototype chain with inline code. So we just generate this little helper. But other than that, you'll note that the code that we generate is the function bodies are always those function bodies that you wrote. It's not like we do massive surgery to the generated code. We don't rearrange declaration orders and so forth. All right. In here, we could, for example, write a constructor that takes x colon number, comma, y colon number, and then introduces a z property here, public z colon number. And then we might, in here, say call super of x comma y, for example. And you can note over here, the code that gets generated, and I could derive methods, et cetera, et cetera, et cetera. All right. So that's classes with inheritance. Let me try to do something else and grab a little snippet from over here. This guy here, yep. I wanted to show another feature that we support, which is arrow functions. I'm gonna demonstrate it with a little sample. Here's a little class called tracker. You see it has an instance variable called count and a start method. And in the start method, we just set up a handler for window.onMouseMove, and then in that, we just increment the counter and output the number of times we've been invoked, and then we run it. So let's try to run this guy over here, and let's try to bring up the browser tools. Go to the console, and you'll note that all I'm getting here is a bunch of nans. So there's clearly something wrong with my code. Now, if we go back and look at the code, we've been bitten by the infamous "you have the wrong this pointer" bug here. I don't know how many of you have gotten bitten by that one before. Everyone, pretty much. Now, if we had actually typed the code in, we would have already noticed that there was something wrong, because if we hover over this here, you'll see that it's of type any. It's not of type tracker, and we wouldn't have gotten statement completion here, and so we would have known that there was something wrong. But if I had just pasted the code in, the problem here is that JavaScript never guarantees anything about the dispointer that gets passed to you. And often you end up with the wrong dispointer if you're invoking through the wrong object. And then what you have to do is you have to capture the outer this and call it that or whatever. So the var that equals this, and then in the nested one, that dot instead of this dot. We've all been there, right? Now, the ECMAScript committee is fully aware of this feature, if you will, and there is work in progress to fix it. In fact, ECMAScript 6 will support what's called arrow functions, what we actually in C# call lambda functions, and one of the defining characteristics of, well, there are two, I guess. One is that it's a more succinct syntax. You don't have to write the function keyword, and you can use a fat arrow. But the other thing is that arrow functions have a lexically scoped this, which means that in an arrow function, the this is the same as the surrounding this, which is actually what you want here. So let's try to rewrite our code to use an arrow function instead. So we'll say arrow, oops, let's not do uppercase E, let's do lowercase e here, arrow. And now you'll note a couple of things here. First of all, it's more succinct, syntactically. But the other thing you'll note is that this now actually is of type tracker, and I would get statement completion on it and so forth. And if you look at a generated code, well, we can generate that pattern that you would have generated. So we inject an underbar this equals the outer this, and then inside the nested function, we reference underbar this instead of this. The thing that's neat about it actually also is that if I get rid of all of my references to this, you'll note that that capture goes away. So we only generate it if you actually reference something from the out of this. Otherwise, it's not there. All right. So that's arrow functions. Another thing we support is modules. And modules are a great way to organize large code bases. Let's say, for example, that I wanted to put my tracker class into a module called utils. I could do it like this. And if you look at the generated code, we generate a function closure, and inside that function closure, we put all of your code. And if you declare local variables in the module, they're local variables that you can close over, and they are guaranteed private. But then you can export stuff out of the module. So you can say export class tracker, and now you'll note over here that we make properties on the module object for all of the things that you have exported. This is a very useful pattern, very common pattern. This is, in fact, how, for example, jQuery is written. But, of course, it's all done manually, where here you get language syntax for it. Now, down here you'll note then that tracker is no longer global. I have to reference it as utils.tracker. But so the type system actually understands modules, right? And if I hover over T, you'll see that its type is now utils.tracker. I could actually go as deep as I want here, and we just get functions marching in over in the generated code. Now I would have to reference it as acme.core.utils. Whoops. Like that. In fact, in order to avoid long names like that, we also support the ability to import stuff. So I could say import ACU is acme.core.utils, like so, and then I could reference it just as ACU here, like that. And if you look over here, you'll see that we just make a local variable, and our code generation needs to be cleaned up a little bit there, but but. Okay, so that's this type of module we call internal modules, and they are basically just, in a sense, they're objects, right? That just start at the root, and then they can be as deeply nested as you want. There's another kind of modules that's common in JavaScript, and that's the kinds of modules used by Node.js, like common JS modules, and there's also the asynchronous module definition, or AMD modules that require JS use. And let me give you a quick demo of how we support those. So let me switch back to, no. Let me open a file here. Okay, I'm going to start with a blank file called server.ts, and I'm going to try to write a 2-module node.js little application in TypeScript. And the way I'm going to start out is by referencing the declaration file for node.js. So I can put a reference comment in my source code, and that tells the compiler that when you compile this file, also compile that other file. And because I now have it in my project, I can say stuff like import HTTP equals module of HTTP. And now if we go look at the definition of this guy, you'll see that we jump into node.d.ts, where we have a declaration of the node module called HTTP. And in here we have all the static type information for node. So that's just done by my module import. So now I can say export function simple server of, say, port :number, comma, message :string, for example. And let's say in here that I wanted to use HTTP, so I may want to say HTTP dot, and now you see that I get statement completion on node, so HTTP dot create server. It actually is a function that takes a callback that has 2 arguments, request and response. So I could now write a lambda here, request response, arrow. And now inside here, if I type request dot, even then I get statement completion. So you see we can flow the types from knowing what HTTP is, therefore what create server is, therefore what request is, therefore what should we show you right here. The same for response, right? Let's try to finish this up just by pasting some code in there. And then, so we're just going to write out a simple response, and then let's basically tell this server to listen on the port that I passed it. And that's my first module. Now what I want to write is another module that uses this module. So first thing I'm going to do is I'm going to say import server equals module of /server there. And then I'm going to say server dot, oops, module, oh, here we go. Then I'm going to say server dot, and you see now I get statement completion on the module I just wrote, simple server. Simple server takes a port number, 1337, say, and the message is greetings, build. Let's do it right. There we go. Okay. And then finally, we'll just say console.log of listening. Done. So now we have our 2-module server. Let's actually just try to use the command line compiler to compile it. So we'll go to that directory where I put it, and you'll see that I have my 3 files in here. I'm not going to tell TypeScript to please compile hello.ts. Now you'll note I won't even mention the other files, but TypeScript will automatically find them because it automatically does a transitive closure on all of your imports and / references and finds the sort of entire project to compile. So if you look now, what got generated, we got 2 files generated. If we type server.js, you'll see that that's basically the code I wrote. I mean, there are almost nothing. My imports have been changed into requires. That's pretty much it. And if we look at the hello file, well, it's same thing, pretty much. Now I should be able to just go hit it on here. So say localhost 1337. And no. Oh, wait, how about I start it first? How's that? This thing is not clairvoyant. Okay, there we go. Okay, let's try it this time. Let's get rid of this guy first here, sorry. Localhost 1337. There we go. There's our little server. Okay, thank you. So that's modules and Node. Let me also show you a couple of other things in terms of larger scale development. In fact, let's go grab one of our samples is called Warship here. Let's try to grab that guy. In fact, why don't we run it first, and then we can look at how it's built. So let's go to Warship here and compile warship.ts, and then let's say start default.html. Allow this. Yep. Okay. So this is a little battleship app where you can first rearrange your ships, and then you can start shooting. And there I hit his ship. Let's see. Yep, I sunk a ship, et cetera, et cetera. So you can play with that one, have fun. So this thing is actually written using jQuery, and it also uses jQuery UI. So here's the source code, and you'll see that I have references to jQuery and to jQuery UI. Now, the immediate advantage of referencing jQuery is when I say $. Here are the 7 overloads that I mentioned earlier, right? The 7 different ways you can use jQuery, pass it strings or selectors or whatever you have. So I'm going to say $of div . And then you'll see here's, for example, @class, which is one of the methods available on jQuery object. Now, I could go to definition and see where that's defined. And that jumps me into, up here you can see jQuery.d.ts. In fact, here you'll see there's a big interface called jQuery with all of the static type information for jQuery's methods and properties. And indeed, you can see that @class has 2 overloads in here. Now, the thing that's interesting, though, is that we also use jQuery UI. And if you've ever used jQuery UI, you know that it then extends $ with some additional methods. It basically monkey patches is, I think, the JavaScript term. It patches itself in by adding additional properties to $. And in order for us to provide a great tooling experience, we needed a way to reflect that in the type system. And we do actually reflect it. So if I say div, and then I go to draggable, for example, which is a property from jQuery UI, and I go to definition, you'll see that I end up in a different file, jQuery UI.d.ts, with the 4 or however many there are overloads of draggable. Now, the way this works is that in TypeScript, interfaces are open-ended. So this jQuery interface, you see, has the same name in the 2 files. And different files can contribute to the same interface. And that's how you can represent this layering of things on top of things on top of things. So I thought that's interesting. Another thing I wanted to show you is, let's try to get rid of all of these files here, is a Windows 8 application. Let's try to go into Win8 here and grab the encyclopedia. Actually, I want to open that as a project here. Here's an app called Encyclopedia. Let's show the Solution Explorer here. And you'll see that, let's go grab, for example, navigator.ts. So longer term, or in the final product, we definitely intend to support a full development experience for Windows Web Apps, or WWAs. This is a sample that is part of the TypeScript distribution currently. We don't currently, in the VS plugin, have project templates or all of that stuff completed yet, but you can still do this. It just takes a little bit more work. But you'll note in here that if I had written this using the WinJS libraries, I would have not written module here. I would have written winjs.namespace.define of encyclopedia, and then down here I would have had winjs.class.define of page control navigator, and da-da-da-da-da. So first thing to note is that we can actually interoperate with WinJS classes. You can derive TypeScript classes from WinJS or vice versa. You can extend WinJS modules using TypeScript modules and so forth. The other thing is we can navigate around in here. If we go to default, for example, here, and let's try to look at this method here. In Windows application model, search pane, get for current view. If we go to definition on this guy, now we jump into winrt.d.ts. And this file is actually 18,000 lines of TypeScript generated simply by importing the WinRT metadata and then writing out TypeScript interfaces. So that's the other beauty of having the metadata available, is that we can just automatically project it. Okay, I think final thing I wanted to show is the TypeScript compiler itself, because it's sort of an interesting sample of a big project. So let me close this solution, and then let me try to open one file here. We'll go to demo/compiler and open up ast.ts here. So this is one of the files from the TypeScript compiler. It so happens to be the abstract syntax trees definition file. If we navigate around in it, you'll see that we can go to the class that imports case statements and whatever in the parser and so forth. Now, one thing you'll note is that I just opened a file, but magically this virtual project appeared over here. Now, the way this is basically us inferring a project from following all of your references and imports. So you'll see at the top here, I reference TypeScript.ts, which shows up over here. And if I navigate into that file, you'll see it references a whole bunch of other files. This is, in fact, the main file for the compiler. And we will automatically traverse all of those and infer your project. And therefore, we now know what the full context is for providing statement completion and so forth. Now, if you look at the TypeScript compiler, it actually has a TypeScript compiler class. And in that class, we instantiate a parser. So let's go to definition on that guy. And the parser, in turn, instantiates a scanner. We could go to definition on that guy. And here you see the scanner. And in the scanner, there's a field called line, which is the current source line that the scanner is processing. We could find all references on this guy. And now you see there's a bunch of references in the scanner itself, and then there's some over in the parser. In fact, here's one, I think, interesting reference, which is this.scanner.line. But then right above here, there's a reference to another line property on a different object called line call. Okay? Now let's say that you decide, I really want to change this line property on scanner. It needs to be called line number. Okay, how would you go about that in JavaScript? Well, you would go through your 25,000 lines of JavaScript code and look at every occurrence of line and make a judgment call about whether that is this property or some other property named line. Right? And this is where the wheels come off in JavaScript development. That's why at a certain point it turns into write-only code, right? I mean, you dare not touch it or do anything. I suppose, yeah. Anyway, let me show you what the experience is like here. Let's take the parser reference and put it down. Oops, that's not what I wanted to do. What did I just do here? It's close. Let's find all references on this guy again here. Let's go back to the parser. Okay. Let's grab this one and put it down at the bottom here. And then up here we have the original reference. So now let's look at the references down here. Now let me go and say refactor and rename this guy. And I'm going to call it line number instead. And you'll note that down here, this guy changes, this guy up here changes, a bunch of other places change, but this guy did not change because it's a different line property. And that's the thing that tooling can do if it has the static type information to power it, right? And this is where, in a sense, this is the thing that allows you to sleep well at night, right? Knowing that, hey, this stuff actually will work when I run it. Thank you. Okay, I think that's it for the demos. Let me just try to sum it up a little bit here. The TypeScript preview is out there currently. You can download it. The download includes the compiler that you saw me use here, language service. It includes tooling inside Visual Studio, as well as the browser-hosted playground. lots of libraries with static typing, and the community has produced a whole slew of them in just the month that we've been out. And of course, samples, language specification. In fact, just talking about just the community response so far has been phenomenal. We already have over 1,000 posts on our CodePlex forum. Lots of Stack Overflow traffic, over 70 static typings for the various libraries out there, tooling support, and so on. So, as I said earlier, we keep hearing that application-scale JavaScript development is hard, and I hope to have shown you today here that TypeScript makes it easier. So please go check it out, download it at typescriptlang.org. Let us know what you think, participate. Thank you very much, and I'll take some questions. Thank you. There are some microphones here, and I'll be happy to take some questions.
With default values in function parameters, is there also support for named parameters?
No, there is currently no support for named parameters, simply because JavaScript doesn't support named parameters, and so there's no good pattern to translate it into. But of course, we do support options bags, and you saw optional parameters. So, typically the pattern in JavaScript is you declare an interface with optional arguments, and then you pass an instance of that.
So you said that because the TypeScript is all compiled down to regular JavaScript, it's universal and all of that, but every browser really has a compliant enough JavaScript engine that none of these features are too esoteric?
Sure. So we support down level, all the way down to ECMAScript 3. In fact, the browser on your phone will run the apps you write here. Now, we have a flag that allows you to restrict it to ECMAScript 3, or you can enable ECMAScript 5 features, which are sort of the more modern class browsers, and then you get property accessors and stuff like that. But you can turn that off, and then we will warn you when you're using features that are not in the down-level browser.
Thank you.
Yeah. Any other questions? Or
Hi.
Yeah.
Hi.
Can you wave your? Oh, there you go. Great.
Hi. So even though, of course, C# is perfect already, are there any features from this that you want to bring over?
Yes. Or from this bring to C# or the other way around?
To C#.
Oh, to C#. I think there are lots of things that we can learn from dynamically typed languages. We do have some support in C# for dynamic using the dynamic type, but right now it also requires a bunch of machinery in a dynamic language runtime. I'd love to make that a little more lightweight than from what it is now. That's one thing that I think would be interesting. I'd love to be able to more natively just process JSON literals in C#, for example, which is something you can't do right now. So those are just a couple of things. Now, going in the other direction, right now the TypeScript preview doesn't have support for generics, but that's something that we do indeed plan to add in the final release, and it'll be inspired by what we do in C#, although it'll work differently. It'll work by erasure, meaning that the generics go away in the compiled code, and they're just purely there at development time to serve as a conduit for trafficking type information in calls and in classes and so forth. Yeah, over here.
Hello. Are there any plans to add a debugger support for TypeScript? So in Visual Studio, I can not only debug TypeScript, but also see the watch window, hover over the variable, and see all the properties and methods.
Yep.
And go in immediate window?
Yes, the answer is yes. There are plans for all of that. Some of it is there today, but not all of it. You can use the browser debugger tools. We do have an experimental switch for generating source maps. So in browsers that support source maps, you can use that. But there will be support in Visual Studio. Yep. Over here.
So can you elaborate a little bit on what you see the role of TypeScript being then once ECMAScript 6 is final?
Sure. I think, the big difference between TypeScript and JavaScript, even when JavaScript becomes ECMAScript 6, is the static typing. ECMAScript has no plans to add static typing, and they have even said so publicly. So we will continue to add that value, and I really do think that is the primary value that we add, because it's what allows the tooling to light up and all of these like big project things to become possible. So we will continue. I think there's even more of a need for TypeScript when ECMAScript 6 comes out, because by then we'll also have a little more Moore's Law, and you can write even bigger projects in JavaScript that need static typing even more, you know. So, yeah.
Yeah, in Visual Studio with ASP.NET, what is the story for your script references and pages for the compiled?
Right, right. If you would in there, you would reference the JavaScript file, and so you arrange to compile the TypeScript at deploy time, if you will, and then you just reference JavaScript. Am I understanding correctly?
As far as compiling it and how that works, so when you make changes in your TypeScript files.
So ultimately, where we want to be, where we're not with the preview, is that whenever you open a TypeScript file, modify it, and save it, then we would automatically generate the corresponding JavaScript file. So it's always up to date. We don't do that currently. There are a few little tweaks we need to make to the module system to make that work always, and we will make those tweaks. And then, but that's the end goal. Is that?
Hi, we're hearing a lot about HTML5 and JavaScript and C++ here, and not much about C#. Is C# still a safe bet?
Oh, yeah, absolutely. I mean, and there are many talks on C#. I know that Matt Torgerson has a talk on async. I don't know if he had it or has it later today. I know of several other C# talks. C# is still going strong. It's just right now there is a big need for better JavaScript tooling, and that's why I've been spending a bunch of time on that. That doesn't mean that I don't spend time on C#. Don't take it that way. Let's go over here.
I know. Is this on?
Yeah.
Hello?
Yep.
So I know it's in